So now let's ask why we use a colour filter. Remember in our double slit experiment, the very first thing we did was pass our white light or our light from a lamp through this colour filter. So why do we do that? Well, the reason is we want our light emitted to have a constant phase difference. Remember, we were saying that was the important thing all the time. We wanted it so our points of intersection, at those points, the interference only depends on path difference. The idea being that whether you have constructive or destructive interference here only depends on the distance the light has travelled. Remember, if in fact our light had a changing phase difference at these points here, then what we'd see is that we wouldn't have, at some points this would be destructive and some points this would be constructive, and so we wouldn't have this fixed pattern, and it's the fixed pattern we want. You really would just see these fringes of light and fringes of dark. They wouldn't be shifting with time and they'd just be constant. If we had a changing phase difference, then we wouldn't have this pattern, so that's why we need that. But the very first thing we see is that two rays of light of different wavelengths, well, they don't have a constant phase difference, do they? And we can see that just by looking at this. Here we've got a trough for this wave and a peak for this wave, but here we've got a peak for this wave and a peak for this wave. Whereas we see normally what we should have is if they're in phase at one point, so they've got a peak and a peak meeting, then they should have that constantly. They should always be in phase, whereas here they're clearly not. Here, it doesn't make any sense to talk about phase difference, because here trough meeting a peak, you'd think that would mean they were out of phase, but here there's a peak meeting a peak, so that should mean they're in phase, so it just doesn't make any sense. So we see, however, that white light, or light from a filament lamp or the sun, that's white light, and it's made up of many frequencies, and we see that when we pass it through a prism. White light goes in, all the colours of the rainbow come out. So white light, the light we're shining at this experiment, is made up of all these different frequencies, and so that's really going to mess with our experiment. We actually see that if we do it with white light, each component colour of the white light will actually create its own fringe pattern, which overlap in places. We get this kind of diagram where we've got this bright white fringe in the centre, but then as we go along, basically each of these colours, we saw for this fringe basing we had our W is equal to lambda D over S. Every single spectrum, every single colour in our light produces this fringe pattern. And what happens is occasionally, but they're going to have, again, as we see here, we were saying if we had a longer wavelength of light, we'd have greater fringe spacing. What we see is that each of them are going to produce a different width of fringe spacing. And so we're going to get this kind of chaotic thing where then, but here you've got this, we see the reds have a different kind of, have a longer fringe spacing, a wider fringe spacing than the blues, and it all gets very confusing. And this, it's perhaps very nice to look at, but it certainly doesn't tell us much about light's interference patterns itself. It doesn't produce this really kind of clear pattern we get up here, where we've just got these white fringes and these dark fringes because they're constantly overlapping, etc. So what do we do to avoid this? How do we produce this really clear pattern we see here instead of this pretty but not particularly useful pattern here? So what we do is we use this colour filter. That's why we do it. What that does is it only allows a narrow band of wavelengths to pass. So we see up here, these waves have different frequencies, different wavelengths, and so we kind of will create this kind of messed up pattern here. But if we put them through this colour filter that only lets this blue light through, and this red light gets stopped, and only this light goes out. And that is what we have up above here in this pattern here. What we see is that when that colour light goes through, that's going to produce this fringe pattern with a constant fringe separation, because only this colour of light, this blue light, is allowed to pass through.
Hey guys, to continue watching this video and unlock hundreds of other super concise and exam board specific A-level physics videos, just click the Snap Revise smiley face. Join me today, and together let's make A-level physics a walk in the park.